Yeah. Check. Hello. Yeah. Hello, everyone. Yeah. Thank you. Yeah. Shall we start now? Yeah. Thank you in advance for attending my talk. So my name is Dr. Siti Faria. I'm currently as a research associate in sustainable maritime logistics, Heriot-Watt University. So I'm from Edinburgh, United Kingdom. And today I'm gonna share my works about quantum optimization for sustainable and efficient port operation from Dover to Abu Dhabi. This talk is mostly about my previous experience working at the port of Dover, and we were a part of quantum technology access program provided by Digital Catapult UK. So I'm gonna talk in detail later. So this is just a bit of me. I want to introduce myself before we start the talk. So I have a bachelor, master, and PhD integrated in naval architecture, ocean and marine engineering. And then during my study, I also I was a research assistant at the University of Strathclyde, and we got several projects with the industry, for example, Lloyd Register and the Scottish government. Then after I finished my PhD, then I was working at the Port of Dover as a simulation modeler analyst. It was part of the UKRI project, actually, between University of Kent and the Port of Dover itself. And during my work at the Port of Dover, I was also involved in the Digital Catapult quantum technology program. So basically, it was like a 6-month training. And then we code the quantum optimization algorithm. Then we plug in into real quantum ORCA computing. Then, yes, so this is my position at the moment. I'm a research associate for Transit and Transport Scotland project. Transit is a UK national research hub based in Edinburgh, and we are looking for the digital twinning of transport decarbonizations. So for the motivation and problem context, we talk a lot about the port today, isn't it? And we mentioned that decarbonizations and efficiency is the main core of our problem these days in the port. But traditional or classical optimization is struggling with to address the complexity at the port. For example, the port operation, like berth scheduling, crane allocation, landside traffic, it requires a lot of combinatorial nature that hard to be addressed by the classical algorithm. That's how quantum computer is really promising to tackling that gap. So this is just my little research before this talk, actually. So I collect several publications and projects about the quantum and hybrid quantum classical optimization in terms of logistic and maritime operations. And as you can see there, maybe just that. So I found several gaps here. At the moment, many works which is related to the quantum at the port is validated by toy dataset. So it is very rare to see the real project with the real port, right? For example, like if you are not really have a direct link to the port itself, like the digital catapult program that I mentioned before. We have I was working at the Port of Dover, and we have a good connection with them. So that's how you can get all the data set. But apart from that, the study and some of the project, they are still using like a data set, a toy data set as a validations. And then for the technology readiness as well, over 80% of study are still in the 1 till 3 readiness, which is only conceptual and theoretical study. So it's very limited to see the real world application in terms of quantum in the maritime. Then majority of the focus of the study is routing and VRP, while maritime and the port itself, for example, the berth optimizations or the lines optimization within the port is like under explorations. The other things that I found out is there is some algorithm bias because quantum annealing is still dominating the work. and lack of diversity in terms of hybrid approach that we found it very interesting, because I just have a talk during the lunchtime that we found that hybrid is, I think, is the right direction for quantum these days, which is the combination of classical and quantum algorithm itself. So yeah, based on that research gap, I found some nice opportunities for quantum in maritime logistics. So for port operation optimization, we can have a look the berth or crane allocations, vessel scheduling, because this problem is very difficult to be handled by the classical algorithm that I was mentioned before. And then this is my current work as well. So currently I'm integrating my port with the road freight. So I think is it very important if we are talking about supply chains. We are not only looking at the port itself, but also the integration within the road side. Because if something goes wrong at the port, it will have significantly affected with the road part. And also it is a good opportunity to have a higher technology readiness in terms of hybrid quantum classical simulation to bridge the current gap. Then it is also important to mention about the IMO target in terms of a green shipping corridor. So the quantum optimization can support also energy efficient routing, and also fuel minimizations. So this is the quantum technology access program that I mentioned before. So basically, it was 6 months training and hands-on coding in real quantum computing, and it was like a ORCA PT Series 1 last year, and it is actually tailored for industry. So yeah, we can see a big name here like Airbus, Arup, DNV, and UK Atomic Energy Authority, and of course Port of Dover, because yeah, I was there. So the aim of this program is we want the industry people to try to use quantum computing by themselves to solve their real world problem. So this was not research basically. So it was like a real problem at the port that I code and run into real quantum computing. So a bit explanations about Port of Dover itself. So Port of Dover is located in the southeast England. So basically, it's just very close to the European mainline, which is France. So it is very critical UK infrastructure, because as you can see there, 33% of all UK trade within the EU is happening in the Dover, right? But there is a big problem, a huge one in Dover. If you can see the traffic there, I took that picture by myself when I was there. So that one is the traffic congestions. Mostly these are tourist cars, but it will also affecting the freight. Because Port of Dover, the eastern part, the eastern dock, they have like a 13 buffer zone lanes. So if the tourists occupy a lot, then there will be like a lesser lanes for freight, isn't it? So the freight needs to queue and congested along the main road. So this is what we did actually in QTAP. So we are formulating QUBO, which is quadratic or unconstrained binary optimizations. So QUBO is a mathematical modeling and acting as the bridge between quantum optimization with the real problem. So first we find what is the real problem, what the things that we want to solve there. Like for example, the port needs to decide which vessel use which berth to minimize the waiting time and full cost, something like that. Then we turn that problem into QUBO, which is the mathematical modeling, right? Basically, it is like we are turning the port scheduling decision into yes or no variable. For example, like a 1 means, okay, that vessel can use that berth, and 0 mean they can't use that berth, something like that. Then we plug in the QUBO mathematical modeling into quantum solver. That quantum solver will test 1,000 of possible solution, and find the most optimum solution that give the least waiting time and the lowest of fuel oil use. So the result will be an optimized vessel schedule that reduce the waiting time, emission, and improve the throughput. So this is the quantum solver that we use at that time. We were using ORCA Computing. It was like a PT Series 1. They have like their own photonic optimizations, which is the hybrid QUBO solver, and they were part of the consortium for QTAP. So we were collaborating with them. But at the moment, I'm also exploring the IBM Quantum and D-Wave for this type of optimizations. And again, as I mentioned before, Port of Dover, this is the eastern dock part. They consist of several buffer zones. And that buffer zone will lead to the border control, because this is like an intercontinent and also inter-nations, so they need to get checked, like a passport control from the French government part. Then after that, they just go along through that way and going to the ferry operator check-in, then finally waiting to be picked up by ferry. The thing is, sometimes there is some imbalanced lanes allocation, which will create the bottlenecks, long queue, and processing delay. So the objective of the QTAP program is we want to optimize the lane allocation dynamically using quantum-inspired optimization via ORCA Computing SDK. We want to combine several operational factors such as the lane use, the ferry capacity, and the schedule, of course, to reduce the congestion and emissions. And that approach will be, again, QUBO formulations with the ORCA quantum solver to find the most optimal line configurations. So this is step by step. It's quite technical, but I'll just skip the modeling part. I will just explain quite briefly. So first, we need to understand the port input data. At that time, of course, we want to know how many freight and tourist car that waiting into that buffer zone. Also, how long that length into that happening in each line. And also, we want to know ferry schedule and arrival rides. And this gives us like 15 till 30 minutes at that time. So we have like a dynamic lane configuration every 15 minutes. So step 2, we need to define the decisions, because each of the 13 buffer lines, they can be either for freight or tourists, actually, right? And this is not fixed split, so we dynamically change the line in every 15 minutes, because sometimes the tourists, for example, they like to come in the early morning, right? Then they will slow down in the afternoon time, something like that. Freight is quite stable, actually, like they just stable during the period that we test in these simulations. But actually, tourist is the one who causing a bit trouble. So after that, we want to measure what we want to minimize, actually. So we built a digital model that calculates a congestion store based on the 3 factors. First is the mismatch penalty, like how many tourist car, how many freight cars versus the lanes available for the each types. And also we have a continuity penalty, like switching the lines type too often, it will be not good and will create confusion, right? So if the car in our simulation switching the line, then they will get penalty. Then we want to keep the lines in balance, so there will be no jam while the next is empty. So because we have like again 13 lines, like, and we want to make it evenly distributed for each lanes. And the goal is to match the number of lanes to vehicle demands and to keep the layout stable over time. Then we also have some constraint here, like for example, okay, we have like a fixed 13 lanes in total, and freight lines must be consecutive at the start. Like for example, they need to queue beside each other. So for example, lane 1 and 2 and 3 is for free. They can't be like a scattered. That's how it works in the real world in Dover. Then, yeah, of course, we send the QUBO via the ORCA. Then ORCA explore the millions of the valid lane patterns in parallel. Then this is one of the example of the output, like a binary vector, like a 0011 means 0 means freight, means the lanes 1 till 3 is for freight. And this is the example because I also run the algorithm not only in the quantum computer, but also in the normal, computer with the classical algorithm. And we can see here, actually, this is the real result. QUBO ORCA solver achieved the best performance with the lowest congestion score, which is like a minus 8.1. So we are showing that quantum approach over the best balance of efficiency and stability. And this is my current work. Basically, we are expanding our journey. So it was start with Dover, right? So now we are expanding the road freight journey beyond the port. So when the freight go to the UK line. And not only, we are not talking about the maritime and freight, we are also exploring the aviations, public transport, and rail as well, actually. And this project is a collaboration project between 69 organizations across the industry, academia, and government. And of course, Port of Dover is also part of the consortium as well. Then, so this is the motivation of transit project. So again, port efficiency alone cannot solve the congestion or emissions, right? Because if we are talking about the supply chain, it will be related to the road freight, right? Then if we are talking about the road freight, it will be related to the public car or even like a rail part, because they are all using that land, right? And then integrated optimization can balance the port throughput and the road network load. And our goal of optimization is to extend the quantum optimization model to coordinate for the port start. For the port operation, we want to coordinate the lane and berth allocations. For the road freight scheduling, we want to optimize the departure timing, route allocations, and also SGV charging schedule, because we are also simulating electric freight. And this is the QUBO approach that we want to apply for our road freight extensions. Objective, again, to minimize the total cost. And also we have like several decision variables like lane and berth allocations, departure timing and route choice, charging and rest scheduling. And there are several constraints here, for example, port capacity, because the capacity is there, right? We can't change it much. And there will be road congestion limit, driver duration, and delivery time. Then for the expected outcomes, we hope to balance the throughput between port and road network. We want to reduce the emissions and travel times under the dynamic demand. And hopefully it can be the foundation for end-to-end quantum enhanced logistic planning. Yeah, and this is just like a brainstorming about my thinking, what we can do actually with the AD ports. So I think is it important to really integrated all the port operations, like from the berth, crane, and yard scheduling across the multiple terminal, because they are managing not only one port, right? Then also it is important to have integration between inland and multimodal logistics, like I explained before. It needs to be linked to the port via freight corridor. Then again, global supply chains resilience, and then emission and sustainable optimization, as I explained before. Yeah, so thank you very much. This is several white paper that we already upload. It's not published yet, but it's there. If you want to have a look our research more deeply, I'm happy to connect with you as well through my LinkedIn. So thank you very much, everyone.
Once implementing the, so setting up your QUBO and identifying your constraints, after the started running the problem, was there any adjustment after the fact? Like, was there maybe observations that then caused to change the formulation slightly, like just to do optimization on the optimization? I'm just curious from going from theory to practical application. Is there anything on that?
Yeah, thank you very much. Yes, it was actually. Sorry. Yeah, thank you. Yeah, it's a very good question actually. It's about validations of what we did in quantum. Is it matching with the real life or not? And the answer is yes, it did. So we got 98% validations through our queuing observation. So in our modeling, we just calculate how many times that freight queue in that line, something like that. And we did the optimization. I just bring my watch and counting the time, and it's like a 98% matching with the real situation in Dover. So that's how I feel like quantum optimization is really promising to tackle this problem. Thank you. Yeah.
There's your next question. I think I shout. What are your end results that you've received from Dover? So in terms of uplift from either wait times or what have you seen?
Yeah. So the wait time is reduced up to 20% after we implement that quantum things. After I don't think this. Oh, okay. So after we implement the quantum planning for the buffer zone lanes, we reduce the congestion up to 20% actually, and that's how we want to expand it into berth scheduling and also continue the journey to the road freight. So that's how we start with a small pilot project. Then we get the port trust. Right? Once they see the result, oh, okay, it's useful, then they want to work with us to continue with the transit project.
So that's going to be a transit full time?
Exactly. So it's like a continuation of my previous work before.
What sort of an infrastructure that you actually require for this?
Sorry?
Infrastructure.
Infrastructure. So at that time, actually, we have ORCA Computer as our partner, right? So it was a PT Series 1. And we got a license-free one, 6 months. And now we are still looking forward to continue that license or, starting collaboration maybe with another quantum computer. But I think it's a good chance for them, because we have Port of Dover, we have a real case scenario. We have a port who are willing to work with us, right? So it's also a good chance for quantum provider itself if they are working with the port. Mm. Yeah, it was like a photonic quantum. So they are basically using laser as their qubit. Yeah. Yeah, definitely. I just talked with Adam actually, and I'm going to chair the panel tomorrow. So yeah, hopefully, finger crossed, we got some some collaboration with IBM, because I'm also exploring ABM and D-Wave at the moment.
Yeah, we are building an IBM data center here.
All right.
Quantum data center. So for which we are actually taking the chips.
What?
We look forward to actually messaging you to see if it was going to have a licensing aspect.
Oh, that will be brilliant. Thank you. So you are from ABM?
No, I'm not from IBM. I'm a local developer here.
All right, local developer.
Levi Investment Holding, doing a local development of quantum data center.
Wow, great. Yeah, let's keep in touch after this talk. Thank you.